Good morning. Chapter 9, Lesson 5 is on page 419. We'll be working on inequalities in two variables tonight. We need some graph paper. We need a ruler for our straight lines. No notebook paper turned into graph paper. Remember, graph paper, straight lines with a ruler. If you don't have a ruler, use your bus pass. Number 23, x minus y is greater than negative 2. Let's make that a little bit easier to work with. X minus y is equal to negative 2, and then we're going to test for 0, 0 and see what we can do with that. Remember, we always want to test for 0, 0 and see what we can work out. So here we go. X minus y is equal to negative 2. Let's make a little t-chart. X and y. My favorite points are x is 0 and y is 0. Remember, this is the y-intercept. This is the x-intercept. Remember, when we set things to 0, we can make a line with only 2 points. So let's give this a shot. If x is equal to 0, we have minus y is equal to minus 2, or y turns out to be 2. So let's put that in here. If I make y 0, this gives me x is equal to negative 2, kind of a no-brainer, so we end up with that. So we have two ordered pairs that we have to play with, 0, 2 and negative 2, 0. Let's stick them over here on our graph. Let's use red. 0, 2 looks like right about there. Negative 2, 0 looks right about there. Let's grab our ruler. Remember, we're going to make straight lines, and looks like something like that. Now remember the other point we needed to talk about when we're making these graphs. Graphs that have, graphs that, well, maybe I should be in red. Graphs that have greater than or less than are going to be inequalities with a dashed line. And graphs that have greater than or equal to or less than or equal to are going to have a solid line. So on this one, we need to turn this into a dashed line, and I'm not sure I can do that in this program. So we're going to have to pretend that this green line is dashed. That's interesting. I think I've just found something I need that I can't do. So this is going to be a dashed line, and we're going to plot those 2 points, 0, 2 and negative 2 and 0. So here's where now with this inequality we have to test for my favorite point, 0, 0. So we're going to test this for 0, 0. We're going to make x 0. We're going to make y 0. We're going to stick it up here to our inequality. So we have x minus y is greater than or equal to is greater than negative 2. So we have 0 minus 0 is greater than negative 2. 0 turns out to be greater than negative 2, so that is a true statement. So when we test this inequality for 0, 0, we find out that 0, 0 also makes this true. So we're going to shade this side of the graph. So our solution space for this thing is everything on the dashed line. So maybe I should, how should I do this? Can I do this? Sort of. You can see that I'm trying to make that line dashed by putting some white paint over the other lime green paint. Looks like that's the best I can do. So there's my graph. Goes through negative 2, 0, 0, negative 2. I tested for 0, 0. The 0, 0 statement turned out to be true, so I shade everything on the right side of the graph where the coordinates 0, 0 are located. Let's try our next problem. Chapter 9, Lesson 5, page 420. This one gives us the graph already, number 37. So I've attempted to write or draw the graph for number 37. And number 37 says, once you've got that, go ahead and make an inequality for what this graph looks like. Well, I'm going to go back down memory lane, and I'm going to say, I think, let's go back to black here. Let's go back to memory lane where we said y is equal to mx plus b. We used the slope-intercept form of an equation. We had that nailed down back in chapter, I forget, 7, 6, 7. And we know that the m is equal to the slope, and we know that the b stood for the y-intercept. So we have that in the back of our mind. We can use this y is equal to mx plus b. And lo and behold, from the graph, we can determine that the y-intercept is at -2. And I think we can even figure out the slope. The rise turns out to be 1, 2. And the run turns out to be 2. So we've got 1, 2, 1, 2 to the next point. So the rise over run, which is the slope, turns out to be 1. So we've got lots of information we can use for our equation. We have y is equal to the y-intercept, which was -2. So y is equal to mx plus b. So let's stick that in there. We have y is equal to x minus 2. Now where did I get that? Well, we had the slope was 1, so I put that in for the 1 for m. We had the y-intercept was -2, so we have an equation in the slope-intercept form. We've just got to figure out how we're going to turn that into an inequality. Well, let's go ahead and test that thing for 0, 0, my favorite point again in this inequality. So we're going to test it for 0, 0 and see what happens. So let's stick in y is equal to 0 and x is equal to 0. So, So we've got x equal to 0 and y is equal to 0. So here we go. We have two options. We can either say y is y is greater than x minus 2, or we can have y is less than x minus 2. Okay. Let me look at the problem real fast. 37. It was a dashed line. Again, this was a dashed line. Let me just write that down. I can't draw it, but we'll have to pretend that it's dashed. So dashed lines means we do not have a greater than or equal to or a less than or equal to. We just have the greater than or the less than. So let's test this out. So 0 turns out to be 0 minus 2. So is 0 greater than -2? Or is 0 less than 0 minus 2? Or is 0 less than -2? So we have to decide which one of these two is true. So it looks like 0 has to be greater than -2. This turns out to be the true statement. This turns out to be the false statement. So when we're all done, we're coloring this side of the equation, which made it true. So our final answer for this equation in this graph, on this inequality with the dashed line, turns out to be y is greater than x minus 2. That would be the part that we were shading on this side. If it were false, then we would have shaded the opposite side. But this is the picture they gave us, so we knew that the answer had to be on that side. We knew that 0, 0 had to make this statement true. Let me go over this really one more time. We had y is equal to mx plus b. From here, we got the y-intercept. We got the slope, 1 over 1. We plugged that into our slope-intercept form of the equation. We had y is equal to x minus 2. But because this is a dashed line, we had some shading. We knew it was inequality, whether it was y is greater than x minus 2 or y was less than x minus 2. Testing for 0, 0, we knew that statement had to be true. So when we plugged this one in with a greater than, that turned out to be true. With the less than, it turned out to be false. We knew the answer had to be true, so we know the answer has to be chosen as y has to be greater than, or y has to be greater than x minus 2. Thanks so much. We'll see you guys all tomorrow.